Welcome to lesson 8.2, Use Properties of Parallelograms. So the big idea as we go through this lesson is to look at these different theorems that explain the properties of parallelograms to be able to find missing measures. So it might be measurements of sides, might be measurements of angles, or it might be measurements of diagonals that can be drawn inside our parallelograms. But to begin with, we need to define a parallelogram. So a parallelogram is a quadrilateral with both sides, or with both pairs of opposite sides being parallel. So parallelogram comes from that idea of opposite sides are always parallel. So if we look at our parallelogram over here, PQRS, we know that side PQ is parallel to side SR, and we know side QR is parallel to side PS. So a few theorems to begin with looking at our parallelograms. Theorem 8.3 states if a quadrilateral is a parallelogram, then opposite sides are congruent. So side QR is the same length as side PS, and side PQ is congruent to RS, meaning they're the same measure. And then theorem 8.4 states, again, if a quadrilateral is a parallelogram, then opposite angles are congruent. So angle P is congruent to angle R, and angle Q is congruent to angle S. So theorem 8.3, opposite sides are congruent. 8.4, opposite angles are congruent. So if we make a couple examples to make sense of those. Here, finding the values of x and y. So it says ABCD over here is a parallelogram. Use theorem 8.3 to find the value of x. So whereas x, it's on top here, side AB is the length x plus 4. Side DC is the length of 12. So we know they're equal to each other. So to figure out what x is, x plus 4 equals 12. Subtract 4 from each side, and x equals 8. Then, if we wanted to figure out the measure angle y here, we know opposite angles are congruent. So angle y would be the same as angle C. So angle y is 65 degrees. Then example 2 here, building off those theorems as well. So it wants us to find the distance FG and the measure of angle G. So the distance of side FG would be equal to HE. So FG is 8 units long. Then the measure of angle G is equal to the measure of angle E. So the measure of angle G is also 60 degrees. And then number 2 here, they want us to find the values of x and y. So in this case, 2x is the measure angle J, which equals angle L of 50 degrees. So 2x equals 50, divide by 2, and x is 25. Then to find the value of y, that side LM here, which would be equal to JK, which is 18. So y plus 3 equals 18. Subtract our 3, and y would equal 15. Now, example 3 is a proof, obviously. These statements have already been filled in. What we need to fill in as we go are the reasons or justifications for those statements. So in this case, it says, if a quadrilateral is a parallelogram, then its opposite sides are congruent. So that's what we're trying to prove. So we're trying to prove one of our previous theorems. They gave us the info that PQRS is a parallelogram. They want us to prove the opposite sides are congruent. So the first statement was that PQRS is a parallelogram. That was given to us, so our reason is given. Then we would need to construct or draw a segment QS. Well, through any 2 points, there exists one line, so that's the reason that we're allowed to draw in this diagonal QS. Then, side PQ is parallel to RS, and side QR is parallel to PS, based on that definition of a parallelogram. Opposite sides are parallel. Then, here for number 4, angle PQS is congruent to RSQ, and angle PSQ is congruent to angle RQS. That is based on the alternate interior angle theorem. Going way back, if we think about one of our first theorems, angles in between parallel lines, our angles, if we're following this transversal, are alternate interior angles. So PQS here would be congruent to RSQ down here, and then RQS up here would be congruent to PSQ down there. Then, side QS is congruent to QS anytime we're saying something's equal or congruent to itself. That is the reflexive property of congruence. And then what we would know is on these two triangles, triangle QPS and triangle QRS, they are congruent by the angle-side angle congruence postulate, which would leave us then with our final statement once we know those two triangles on the interior of our parallelogram are congruent. All their corresponding parts are congruent. So side PQ is congruent to RS and QR is congruent to PS. Based on the reason, corresponding parts of congruent figures are always equal or congruent, and that theorem is the corresponding parts of congruent figures theorem. So this proof is showing that theorem 8.3 here is true for all parallelograms. Then, refresher on that idea of interior angles. Interior angles are the ones that would be in between two parallel lines if we cut it by a transversal. Then, consecutive interior angles, if we're following a transversal, they are on the same side. So X and Y here are consecutive interior. So the consecutive interior angle theorem states parallel lines cut by a transversal, then the pair of consecutive interior angles are supplementary. So supplementary meaning add to equal 180 degrees. So angle X and Y here are supplementary. This allows us to come up with theorem 8.5 for a parallelogram, which states if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So angle X and Y here are consecutive next to each other. So X plus Y equals 180. Or if I was looking at angles P and S down here, they are still consecutive, so they have to add to 180. S and R add to 180. Q and R add to 180. So consecutive interior angles are supplementary, meaning the X and Y in this image added together would equal 180. So let's look at a couple of examples related to that. It says here in this desk lamp, as shown, part of the extending arm up here creates a parallelogram. So it created our parallelogram ABCD. Then it says the angles of the parallelogram change as the desk lamp is raised or lowered. Find the measure of angle BCD when the measure of angle ADC is 110 degrees. So angle BCD and ADC are consecutive interior angles, meaning they're supplementary or together they equal 180. So if ADC is 110, we know our missing angle plus 110 is 180. So our missing angle of BCD is 70 degrees. Then we get into our final theorem for parallelograms that we're working with today, and that's theorem 8.6, which is based on the diagonals of a parallelogram. So our diagonals would be segment QS and segment PR. So what this theorem states is if we're dealing with a parallelogram, then the diagonals bisect each other. So that would mean QS gets split in half, so QM would equal MS, and PR gets split in half, so PM would equal MR. So using that idea, we can find a midpoint of our parallelogram here. So in this case, it says the diagonals of parallelogram LMNO intersect at point P. What are the coordinates of P? So all you have to do is pick one of your diagonals. I'm going to use OM, and we want to use the midpoint formula. So you add the x values, divide by 2, add the y values, divide by 2. Well, it's easy when point O is at 0, 0, and M is at 7, 4. So x values added, 7 plus 0 divided by 2. Y values added, 4 plus 0 divided by 2, gives us point P at 7.5, comma 2. Then our last example for today's lesson is finding the missing measures or indicated measures in parallelogram JKLM. So first they want us to find the distance of N to M. So we knew Kn was 2, so Nm, the other part of that diagonal, also has to be 2. Then for number 4 here, the whole segment Km, if we know Kn is 2 and Nm is 2, 2 plus 2 would give us the whole segment of 4. Then they want us to find the measure of angle JML. So that would be this whole angle down here in the bottom right, from J over to M up to L. Well, we know that angle plus angle J down here are supplementary. So 180 minus angle J here would give us our angle over here of 70 degrees. And then they want us to find the measure of KML. So from K to M to L, just the upper half right here. So in that case, we knew this one was 70. The whole thing, I should say, is 70. This part of it's 30. So JML minus JMK will give us angle KML. So 70 minus 30 gives us the missing part right here of 40 degrees. So today's lesson really can be summarized in our different theorems, 8.6, then going back to 8.5, and 8.4 and 8.3. Those 4 theorems allow us to find a bunch of different measurements related to parallelograms.